Hello and welcome back. I'd like to, before going into more complex math, just describe what our number system is and how it's just a system of relativity, meaning that when we talk about 1 unit or 1 unit of distance or whatever you have, what we're meaning to say is relative to something, because any movement has to be compared as relative to another object or another concept. Otherwise, we don't have any barometer to compare something to. So, again, we'll start off with the concept of nothingness, which is up to you how you want to look at it. As a blank piece of paper, I don't know. But we'll use a mathematical symbol because that's how math, the language, says that nothingness is defined, and we're going to put this round circle and call it 0. Okay, and so, well, if we have a number 1, which means 1 unit or 1 pizza or whatever you want to make in your mind. I made this as a pizza pie. So if we have 1 relative to nothing, then we have 1, and I'll put over 0, meaning relative to nothing. Now, of course, as we described in the last thing, to put nothingness into something would go infinite times and probably would never recreate the somethingness. So, but this could mean a distance of 1, meaning that if we had our number line, which I think I draw here, I do, and relative to the nothing mark, I move a distance of 1. So that could be 1 relative to nothing. Now, or it could be 1 pizza relative to no pizzas would be a full pizza. Because if I have a full pizza and it's relative to no pizza, the total distance or the total amount of pizza that grows out of nothing would be 1 full pizza. Now let's look at 1 relative to 1. Well, we could also write that as 1, or we could write it as 1 over 1, or 1 relative to 1 itself. So, different than this 1 relative to nothing, we would have 1 pizza relative to 1 pizza. So, if we compare the other concept where I said, okay, I have a full pizza compared to no pizza. So I grew a full pizza out of no pizza. But here I'm not growing any pizza at all. I'm having a full pizza to start off with. And I'm finishing with the same full pizza. So as in this concept, something grew out of nothing. I had a nothingness and I grew it into a pizza pie. Whereas here, a pizza pie existed and it remained as a pizza pie. So that's a concept right there that has to be looked at in mathematics. So as far as a unit concept, I grew a unit from 0, or this is just a unit. It just is a pizza. It never grew from 0 to 1 to appear as a pizza. It just stayed as a pizza to a pizza. So in this concept, it just instead of 1 is going from nothing to 1, whereas the other one is just staying on 1. So that could be a distant concept. So 1 over 1 in our example here will be unity, where you have something, and relative to the something, they're both exactly the same. So they're at unity, or this is a unit. Let's take an example of a number, and the number just by our language is called number 3, and it has a symbol. I think you're aware of that symbol. None of these had to be written like this. This is just an agreed upon language. The 3 didn't have to be written like this. I believe it's Hindu Arabic, but forgive me if I'm wrong how this symbol came about. Or even the word 3, which is tres in Spanish, and I don't know the other languages, but it's just a concept. So here's 3. And when we say 3, we mean 3 units. In math, that's the language we use in units when we count something. So in this case, we're doing pizzas, so we're going to go, this is 1. This could be 1 and 1. So this could be 1 plus 1 plus 1. I could say it like that. Or I could say, hey, let's make a language where I'm going to be able to say this, this, and this without having to say it every time. So I'm going to say, okay, let's make a number and a symbol, and we'll call it 3. But you'll know when I say 3 that I mean 1, 1, 1. That's the convenience, and that's the beauty of language. To convey a concept without having to go through everything piece by piece by piece. It's a more beautiful way of saying something, but it's also a shortcut. Just like this language I'm speaking to you in is just, it's a language, and I'm hoping to convey what I'm trying to convey using this language, this English language. So let's see our 3 again over nothing, or relative to nothing. Then we grew 3 whole pizza pies from nothing. But 3, here's another 3 relative to 1. Well, I could say that here's 3 pizza pies. And then now relative to 1, well, this one, I didn't grow any new pizza pie because this was our original one. So this means that there's 2 brand new pizza pies that are grown relative to this 1 pizza pie. So there's different ways of looking at this. What the language of math is saying is that 3 over 1, it's saying is 1 because this goes into this 1, 2, 3 times. But it didn't need to be like that. It's just the agreed upon way that we are using the numbers. It could certainly have been this other way where, okay, you already have that pizza, so let's just count our new pizzas. The same thing on a number line is that this distance relative to what? Well, relative to 0, I move the distance of 3. But in this case, if I start off on 1 and I go to 3, because this already crossed out, I'm already done with that part. So now I'm only moving a distance of 2. So when we use numbers, we should always keep in mind that we're moving numbers or anything relative to something else. Otherwise, the number in and of itself makes no sense. Because what's a 1? Well, 1 only makes sense if it's relative to something else, because 1 in and of itself doesn't really mean anything. So everything has to be relative to something in order to have meaning. Otherwise, there's no net movement, at least in mathematics, in the dual state of math. That's what the movement is relative to something else. Non-duality is another topic that maybe I'll explore some other time. But let's go on, and we'll do 2 over 2 equals 1. So again, what's that saying? That's unity again. So if I have 2 pizzas, and I divide it by 2 pizzas, those 2 pizzas are exactly the same on each side. And so it could be reduced, so to say, to 1 because there's complete unity. This top equals that bottom. It's complete unity. If I had just the slightest amount of extra something there, it would no longer be unity. Or if I had the slightest amount of something extra there, it would no longer be unity. Or if I had even the slightest negative something there or negative something here. It's only when the 2 objects, either they're 2 objects or 3 objects or 4 objects, equal the exact same number on the bottom, the relativity is the same, that we have 1, which is a unit or unity. So unity and unit kind of mean the same thing. Now here's the number system that we have, which is based relative to 1, and I'm going to write it out. 0 over 1, 1 over 1, 2 over 1, 3 over 1, 4 over 1, and negative wise. This is our number system. What it's really saying is relative to 1. We're using these concepts, it means relative to this one unit. Like here, 3 relative to 1. Here's relative to 2. So I could write a new number system that's relative to 2, where this is now 2 over 2, which is the same as 1. And now I'll have 3 over 2, which is 1.5, and 4 over 2 is 2, and 5 over 2 is 2.5. And here's 0, and negative 1/2, and negative 1. And you can see how this system is just like the other one, except it counts by 1/2, because now it's relative to a 2. But it's the same. I could have made this number system. In fact, I just did. But the concept is what's important here. Where is unity and what's being measured relative to what? That's the purpose of our number system. That's the purpose of even the distances that we're moving. Relative to what are you doing? Fine, this is 2, but we don't know what a 2 is. What's 2? Relative to 0. Oh, it's a distance, 1, 2. But 2 by itself is just a concept that we have to define. And in this case, when we talk about numbers, I'm going to define 2 as 2 pizza pies. And so I can make another number system relative to 3, which this would be 3 pizza pies over 3 pizza pies, which would give me 1. And here we count up by a third until we get to our next number 2, and so on, and the other way. And we can do it with 4s, and we'll see that we go by a quarter, but we could still count infinitely each way, where I get 1 here, and then I'll have 1 1/4, 1 1/2, 1 3/4, 2, and to infinity that way, and to infinity negative way. It's just that now what I'm relative to is the number 4, or the concept of 4 pizzas, which I don't have here, but it would be an extra one of these. 4 pizzas relative to 4 pizzas would be 1, and 5 pizzas relative to 4. Well, the 4 pizzas and the 4 pizzas would either cancel out, and I'd be left with 1 extra pizza out of 4, which would be a quarter, or I could call this 1 1/4 if I count the pizza itself. So all this is just language and convenience. When we talk about negatives, what are we talking about? Well, we're calling a negative number like in debt or not. Like, for example, I am hungry. Well, that's like, okay, you're in a positive state of hunger. I am not hungry. Well, that's like you're not hungry, you're negatively hungry. Well, I am not hungry. Well, now we have a double negative, and we're saying, okay, well, conceptually, if you're not hungry, well, that means that you must be hungry, because not hungry is not having hunger. So not having hunger is the opposite, and that means having hunger. So these are just concepts and languages. If we move negatively, we're moving to the left in our language, where we said negative is on our number line going this way. I could have put negative on the other side, but it was decided not to do it that way. Same thing, and relative to what? Well, we called 0 on our number line the relative point. So relative to 0 moving that way. Or positive, going to the right, because that's what our language defines, going this way. So move me positive, well, we'll go that way. How about imaginary numbers? Well, move me up, go that way. Move me down, go that way, which is I for imaginary, another symbol that's just being used to describe a concept. Move me up 2 units relative to 0, 1, 2. Move me down 2 units relative to 0, 1, 2. Move me to the right relative to here, which I'm going to call 0, 1, 2. Move me to the left, negative 1, negative 2. This was just all created by necessity for more and more language required. Rotate me. Well, I want to rotate that way. Well, now I'm going to multiply by imaginary I. And these are just more languages that were developed. And to rotate the other way, then multiply by negative I. And so, in summary, mathematics was a language, and it's a very useful tool to convey concepts. And here is a perfect example where it's much easier to write 100, and you can conceptually see 100 pizzas in your mind, than having to sit down and write out this symbol of pizza, which I created. This is my pizza symbol. To write that out 100 times would be a lot of work. It's much easier to just write that. And even to organize this, I did it by tens. I didn't have to. I could have organized it by fives, but I did it by tens because that's the way our number system likes to organize something. It's by tens. That's the decimal system. But I could have done by fives, but I'm doing by tens. Okay, so I could write it like 10. Instead of counting out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Those are all symbols which we get. Then, I could either go, okay, 10 plus 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 10, I'll get 100. Or I can make even easier symbols. Okay, I'll take 10 and I'll take it 10 times. That's a new concept, a new symbol required. I get 100. Or I could use exponential. I'm going to take 10 times, or 10 times itself, which is here, an exponential function. And that's another shorthand way of coming to the same concept. Much easier than like drawing all this stuff out. And much easier, that's what a language is. It just is a tool to convey information. And math is no different. So I hope that after today's little lesson that we see again that math is a tool. It's very convenient. It's a useful tool for doing all kinds of things that need a method of describing different concepts. It certainly simplifies our life. But again, we created the language. We created the system. It didn't need to be based on tens. It could have been based upon anything. These symbols were chosen, and they don't have any intrinsic meaning. They're only given meaning after a whole consensus of people agree on it to give it meaning. So let's look at math as the useful tool as it is to do certain things, like a hammer is useful for banging in a nail. And I'd like to stop looking at math as some kind of mysterious force that's somehow going to give us the answers to the questions of the universe. If anything, like I said before, it's pointing to the universe being completely whole and connected and complete unity, and it's infinite. Because there's no amount of times that I can chop this up in my mind's eye. I could chop this up infinitely times. So we have complete unity, and we have an infinite number of times that unity could be chopped up into pieces. And that's pretty much mathematics. How you choose to slice up the pizza is up to you. But the pizza is whole and complete. And now it's up to you to create what language you would like to use to chop up your own pizza pie. And I thank you once again for your time, and have a great day.